cycle time is much longer to drill through the part than it is to mill the part. We can mill the part in 4 minutes. It takes us 10 minutes to drill it.
The crankshaft is the heart of the engine. It's refined with an induction hardening machine from Germany that rapidly heats it to 1200 degrees and then quenches it with cold water. This makes the surface even harder and more resistant. This is the result. The crankshaft will convert the movement of the pistons into rotational motion with the help of so-called connecting rods, thereby making the wheels turn. It's installed in the engine block. The next components to be put in place are the valves. These are oiled manually before being inserted. 4 per cylinder, a total of 24. The cylinder head is put in position with the help of a crane. The engine block is now complete. It's transported to the next station by what's called an AGV, an automated guided vehicle, which is basically a self-propelled robot. It stops at every workstation in the factory, waiting in place until the parts have been assembled before moving on.
There's a guide wire in the floor. The guide wire is a way to communicate with the AGV. There's a sensor on the bottom of the AGV, and it holds the wire and it follows it the whole way around. The only time the AGV stops is if you're in front of it. There's a safety laser that will stop automatically. Or there's things in the ground called RFID tags, where the engine stops for each station so we can do the appropriate work onto it. When it's made it can manipulate. Every station you're going to see is moving and turning, and that's, again, that's for a position for the operators to be able to build appropriately at each station.
In about 3 hours' time, the engine will be started for the first time. But before that, another 400 fixtures need to be mounted with the use of special tools, such as this electric ring spanner, which opens with the push of a button. In the past, the fuel line fittings had to be tightened by hand. The electric tool saves 70 seconds per fitting. The bolt is secured with one push of the button, and a second push releases the grip.
So you can't get a normal gun on this because there's a line going in there. So when he tightens it, so as you can see, I can't get it out because that gap, as you can see there, see the gap is over here, I can't pull the line out. So this gun is used, it has a dual trigger, so go ahead, Barry. So he hits it again, I can pull it in and out.
There's a specific torque for each screw on the motor. That's why employees use digital torque wrenches. These record exactly which screw on which motor has been tightened when and how tightly. All this information is sent to the central computer via Wi-Fi. The bolts and nuts are first tightened by the workers with a conventional fast-turning cordless screwdriver and then with a torque wrench. The AGV only moves on once the green light's been given. If a part is missing, the engine remains at the station. This 6-fold torque wrench is used for the crankshaft damper. It tightens the 6 screws with the correct torque in the correct order. This ensures that the damper lies completely flat against the engine block.
In the 13-liter crank damper, we have 6 fasteners. It's a 2-stage torque, so rather than doing 12 hits with a handheld torque gun, you do two cycles with this multi-spindle torque gun.
In the next step, the engine is fitted with 4 oil filters, 3 large ones and 1 smaller one. The engine will have capacity for up to 36 liters of oil. The oil only needs to be replaced every 54,000 miles. The job of the filters is to keep the engines lubricated. To do this, they filter out any burnt oil particles, along with dirt and dust from metal abrasions. Then comes the inspection. At 7 separate stations, workers check by hand whether all the parts have been correctly installed. The engines are about to be started. The yellow AGV's work is done. From now on, the units will be transported on a conveyor belt. The engines now enter the factory's test area. Before testing begins, the engines are filled up with oil and other liquids.
While we're filling it, we're rotating the crank. It rotates at about 3 RPMs. So while we're filling it, it's rotating and pushing the oil into the cavities where we need it.
Filling up takes 60 seconds. The first test can begin. A worker attaches pipes, cables, sensors, and exhaust pipes to the brand new diesel. This is done on a turntable. While that's happening, another engine on the other side of the turntable is tested in parallel. Then the positions are switched. The engine that's been tested is moved along, replaced by the next one on the test stand.
I love this job. I wouldn't want to do nothing else, I don't think. It's keeps you busy, but it's just neat to do it. And it's a challenge every day to try to stay on the same pace. I really enjoy it.
Each new engine runs on the test stand for 4 minutes. There's no time for it to warm up, which is why this is called the cold test. During every shift, at least one engine is randomly selected and taken off the assembly line. This engine is put through a hot test, tested for 22 minutes at every RPM range. If everything's working, the next stop is the paint kitchen. All the engines are painted green. Any parts that shouldn't be painted are taped up. Robots spray the engines in 2 paint booths.
A lot of rust preventative as well that goes along with it, and also on the customer side of it, they do really like seeing that green engine whenever they open up the hood.
Once the paint is dry, workers remove the protective covers. Now the 13-liter V6 Series 6-cylinder diesel engine is ready for transport to New River Valley. It weighs more than a ton. Depending on which production week it's earmarked for, it will now either be stored for a few days in the warehouse or go directly to the shipping dock, where it will be loaded onto a trailer. Monday morning. The early shift at the New River Valley plant is getting started. More than 300 truckloads of parts have to be unloaded per day. This is done at approximately 120 loading ramps around the plant. Only parts that are being stored temporarily are sent to the high bay warehouse. All other loads, such as the tires, are installed immediately, including the engines from Hagerstown. Forklift trucks take them directly from the loading ramp to the assembly station.
I have operators unloading wheels and tires, engines and transmissions on both sides, and then staging them in order, sequence for the line. You pick up the next one, that's the next truck that's going down the line. They're sequenced from Hagerstown, then we sequence them right here on the dock to go to the line.
Meanwhile, small parts are delivered in standardized wooden crates and brought to the high bay warehouse. The plant requires about 750,000 cable ties every day, so they're stored here in bulk. Logistics specialists distribute them in small quantities to the respective assembly stations. The high bay warehouse consists of 9 5-story shelf units. 7 of them are loaded and unloaded by robots, 2 by humans. A team of 20 warehouse workers constantly checks which part is where it needs to go, and how long it will take to reach its destination.
Then it generates what we call a ticket. This is a receiving tag. A zip tag is what we call them internally. This tells us parts are received now with the quantity and where it's going, 58. So they'll take it and place it on the conveyor. When it goes through, there's a curtain on the conveyor. That reader will read our zip tag, and it'll tell it where to take it in an open cell down here. This basically has 10,142 cells in it. So there's no way somebody can memorize where every package is in there.
Each loading and unloading procedure is recorded in the main computer. 2 human-operated cranes are responsible mainly for bulky goods, larger crates that can't be loaded by the robot cranes. The crane operator transports the wares from the ground to a free cell, unloads them, scans and saves a ticket and the location, then returns to the warehouse for another crate and starts the procedure all over again. When material is needed in production, the high bay warehouse automatically sends it via this conveyor belt. More than 14